Today we're going to use elimination to solve system of equations. And this is a continuation of lesson 4-6, except for now we're going to work with problems in which the coefficients are not the same on either variable. So if we look at this problem, the coefficient on x is different and on y. So we need to figure out how to get the coefficients to be the same. So you can either use multiplication or division to do this. And when you do the problem, you have to multiply or divide every term in order to stay equivalent. So I'm going to do multiplying the second term by 2 in order to get the x's to be the same. So the first equation is 2x plus 3y equals 6. The second equation would now be 2x plus 4y equals 10. And then I'm going to use my process of deciding, do I add or subtract? So 2 and 2, I need to subtract to eliminate. That cancels this. 3 minus 4 is negative y. 6 minus 10 is negative 4. We're going to divide by negative 1. Y equals 4. So that's our first solution. Now you're going to substitute that back into one of the original equations. I'm going to use the second one. So x equals 2 times 4 equals x plus 2 times 4 equals 5. X plus 8 equals 5 minus the 8. X is negative 3. So the solution to this system is negative 3, 4. Remember to check your solutions when you're done. 2 times negative 3 is negative 6. Plus 3 times 4 is 12. Negative 6 plus 12 is 6. Negative 3 plus 2 times 4. Negative 3 plus 8 is 5. So that works, and then move to the next problem. So when we look at this system, we either try to get the x or the y to be the same. If I look carefully, if I multiply the second equation by 3, I can make 9 and have matching y coefficients. So I'm going to leave the first equation alone. The second equation is going to become 6x minus 9y equals 18. And now I'm going to add in order to get rid of the x or the y. So then y cancels. 3 plus 6 is 9x. And 9 plus 18 is 27. Divide by the 9, x is 3. And then I substitute that back into the original equation. 3 times 3 plus 9y equals 9. 9 plus 9y equals 9. If I minus 9, 9y equals 0. So y is 0. So the solution is 3, 0. In the next equation, if I want to get the x or y to match, I'm going to work with the y. I'm going to multiply by 2. So 2y equals 4x plus 20 is the first equation. The second equation is 2y equals 4x plus 20. And we notice that both equations come out exactly the same. So if I want to eliminate the y, I subtract. I'm going to get 0 equals 0. Or infinitely many, since they're the same equation. If you think about when we graph that, they would have the same exact line. And the last problem, when we look at the x and y, neither the x or the y is the same. I cannot multiply either equation by one number to make the other. So if I want to multiply the x, I'm not going to get a match if I want to multiply the y. So in some cases, you have to multiply both equations. So what is a common multiple that goes into 3 and 5 would be 15. Okay, so you're going to multiply the top equation by 3 and the bottom one by 5. 3 times 5 is 15x. 3 times 3 is 9y. 3 times negative 10 is negative 30. 15x plus 25y equals 130. To get rid of x, I'm going to subtract. 9 minus 25 is negative 16. And negative 30 minus 130 is negative 160. Divide by the negative 16, y is 10. And then again, substitute that into one of the equations. 5x plus 3 times 10 equals negative 10. 5x plus 30 equals negative 10 minus the 30. 5x equals negative 40. Divide by 5, x is negative 8. So my system of equations is negative 8, positive 10. So once again, if your coefficients do not match either one of them, you can multiply both equations in order to get a common coefficient.